Yo, yo, yo. This is Mr. G coming at you live from KDMS, bringing you a video about area of composite figures. So, the big thing today, guys, is one, if you have not watched the video for area of a circle, please do so, and then you can go on to this one. But composite figures. So, composite figure, you guys, is a shape that's not a shape. So, it's a figure that is not a single, simple geometric shape. Okay, so if you look at this shape right here, this would be a composite figure. Okay, and what we can do though is we're going to find the area of these. Okay, we're going to use some different formulas. But what we could do is the cool part about composite figures is they normally can be divided into shapes that we do know. So right now I just divided this. This looks to me like a square. And this looks to me like a parallelogram. Okay, I'm not going to write that because I probably will spell it wrong. But this looks like a parallelogram. So what I can do is if I know the formula of how to find the area of a square, and I know the formula for how to find the area of a parallelogram, then I can find the area of both separate shapes. So I can find the area of a square, find the area of a parallelogram, and then I'll just add those two up together to get my area of the entire figure. Okay? That's all you're doing today. But the big thing here first is your formulas. Okay? Now, a lot of these you've already seen before. Okay, you guys at this point in time should know how to find the area of a square or a rectangle. You just take your length and you multiply it by your width. Okay, or you just take your length and you multiply it by your width. Now, notice how I wrote L and W in different spots. That's because it doesn't matter which one's your length and your width. As long as you multiply the two sides, you're good to go. Okay, parallelogram is the same thing. Okay, there's your height. And then either one of these could be the base, but you're just multiplying the height of the parallelogram by the length of the base. Okay, so it's important to know these formulas. Triangles, okay, again for triangles, if you need to draw what the height looks like, there's your height, and then your base is the bottom of the triangle. The height is going perpendicular to the base, going up and down, tell you how tall that triangle is. Trapezoid. Trapezoid is probably the most complicated of the formulas, but it's still really easy because this one even uses like just some like addition and whatnot. But it says base 1 plus base 2. So the trapezoid is the two lines that are parallel. That's your base 1 and your base 2. Okay, it doesn't matter which order, which one's base 1 and base 2, because when you add them, you get the same thing. And then your height is just like your parallelogram. It's the height of the trapezoid. The big thing is that you have to add these up and then you got to divide it by 2 though. Okay. But trapezoids are your friend. We like trapezoids. Another example of a trapezoid, and maybe you can draw this, is it looks like it starts off like a rectangle, and then it has like a triangle sitting on the end. This is also a trapezoid. I know this isn't slanted the same way, but you can cut it off right here. This is still a trapezoid. So this formula would work for a shape that looks like this as well. And then, of course, a circle. Okay. One thing that you might want to add, or you don't need to add, but we can just look at it. If you have a half a circle, the formula stays the same. It's still pi r squared. But once you find the formula for the half the circle, just divide the whole thing by 2. Okay? All right. So again, guys, what we're going to do is we're going to find the area of composite figures by dividing the figure into multiple shapes and find the area of each shape. And then we're going to add them together. So we're going to look for parallelograms, rectangles, triangles, trapezoids, circles. And if you have these formulas in front of you, it shouldn't, all we're going to do is plug some stuff in, multiply, and go call it there. So here we go. I have an ice cream cone. Okay, ice cream cone's not actually like a real geometric shape. Okay, but if we look, the ice cream cone is made up of a half circle and a triangle. Okay, so what I need to do is I need to figure out what the area, I'm going to move this over a little bit, the area of this half circle is. And I need to figure out what the area of this triangle is. One good practice with finding the area of composite figures is once you figure out what shapes you're going to do, draw them off to the side like this. I know this has a radius of 5, this half circle. It's given to me here. So now I know exactly what I'm finding the area of in a simple shape. So I drew it off to the side here. I know my triangle has a height of 8 because that was the height of this triangle, right? The radius of this half circle is 5. So that means the base of the entire triangle is 5 plus another 5, right? So this whole triangle has a base of 10. Okay, so what I did is I took this triangle, I flipped it around so it's standing up. I gave it a base of 10 and a height of 8. Now I should be able to use my formulas in order to solve for area for both of these. I know area equals pi r squared, and I know area equals base times height divided by 2. Okay, once I take these two areas, I'm going to add them up, and that's going to give me my total. So for my half circle, we'll do these in different colors here just to make it stand out a little more. Area is pi times my radius squared, which is 5 squared. So that means my area is 25 pi. Okay, and then again, what we can do sometimes is, especially what I'm going to do for the sake of this video, is I'm going to use a calculator just to save you guys time, because you don't need to see me multiply 25 times 3.14. Okay, and it's 78.5. So, depends on where. There we go. So I've got my half circle. The area is 78.5 inches square. Now, the area of the triangle. Base times height divided by 2. Well, my base is 10. My height is 8. And I know I got to divide it by 2. 10 times 8 is 80. Divided by 2 is 40. So now I'm just adding up the area of the half circle, which was 78.5, the area of my triangle, which was 40, and I'm adding those up to get, let's see, line up my decimal, 5, 8, 11. So the area of this entire figure is 118.5 inches square. Okay, let's look at another one. Because guys, all it is using our formulas, identifying shapes and using our formulas. So the first thing I want you guys to do on your own is figure out what shapes you want to divide this figure into. Okay, there's a lot of possibilities. They're kind of already drawn out there for you though, but let's see if we can simplify. We want to go as few shapes as possible because that's the least amount of work that we have to do. Okay, so try it on your own real quick. All right, here's what I would have done. I would have divided it into triangle, rectangle, trapezoid. Okay, this whole thing right here is my trapezoid. Now you can divide a trapezoid into two triangles, but why do that when we have a formula that works for this? Okay, so now I got to figure out what all my dimensions of each shape are. I know my height of the triangle is 9. I got to figure out what this length is right here. Okay, well this is 15 here, which means this is 15 here. So there's my base. Okay, now let's move on to my rectangle. My rectangle, that's 4 by 15. That one's an easy one. Now let's do the trapezoid. The trapezoid, let's see, the height of the trapezoid is 4, base 18, and a base of 15. I can now have all my dimensions. I should be able to use my formulas in order to add these all up. Okay, so the trapezoid, base 1 plus base 2 divided by 2 times my height. So take out my two bases, 15 and 18. Add them up. Divided by 2, multiply by the height of the trapezoid. Okay, this is 33. This isn't the most friendly of trapezoids, I guess, huh? So I'm going to get 15 plus 18 is 33. Divided by 2 times 4. Okay, and then 33 divided by 2, that's going to give me 16 and a half. I'm going to move over here, just kind of ran out of room. 16 and a half, that's 33 divided by 2, so I got 16 and a half times 4. And then again, I'm just going to use a quick calculator for you guys. Okay, 16 and a half times 4, so 16.5 times 4, and that's going to give me a nice friendly number of 66. So I figured out the area of this trapezoid is 66. Okay, the rectangle, just 4 times 15. That's an easy one. Okay, 4 times 15 because I'm multiplying my two sides, and I get 60. So the rectangle is 60. Okay, and then finally the triangle, base times height divided by 2. So I have 9 times 15. Oh, I should have done this in purple. Divided by 2. Okay, and 9 times 15 is 135. So now I've got to divide 135 by 2, and I get 67.5. So now that I have found, so I'll draw an arrow to 67.5. So now that I have found the area of this triangle, I have found the area of this rectangle, and I have found the area of this trapezoid. I just have to add up these three values to get my final area. 60 plus 66 is 126. Now I got to add that with 67.5. Again, real quick reminder, notice how I'm adding up my decimal. So I added these two up to get me my 126, just so you guys know. And then I'm lining up my decimal just so I make sure I don't make any mistakes when I add. Now, the big thing also here is that make sure that you don't, make sure you line up your decimal, okay? And then make sure we also include our dimensions afterwards. These are centimeters squared. Okay, one more. Just get extra practice in here. So again, divide it into 3 different shapes. Try to do it on your own. And then if you can, maybe even try to find the area of this one on your own. So pause the video, divide it in the shapes, find the area, and then you can check to see how you did. Okay? All right, so here are my shapes. Triangle. So I have a triangle with a height of 4 and a base of 7. Okay? My rectangle has sides, it's really a square, 7 times 7. Right away, I'm just going to tell you, the area of that's 49. 7 times 7 is 49. And then it looks like I have a parallelogram. So it has a height of 3 and a base of 7. Okay, so 7 times 3, because parallelogram, it's just your base times your height. It's simple. So it is just 7 times 3, which is 21. So I already have the I already have the area of both my square and my parallelogram. So now I just have to figure out the area of my triangle. So triangle, you take your base, multiply it by the height, and we divide it by 2, just because triangles make half of a parallelogram or a square or a rectangle, which is just length times width. So that's why we're dividing it by 2. So we get 28 divided by 2, which is 14. So I really need to add up. So I know this area of this figure is 14. We know that this one was 49. And we know that this one was 21. I just need to add these 3 values up together. Okay? Just adding these up. 21 plus 14, 21 plus 49 is 70. 70 plus 14 is 84 square yards. Okay? That's it, guys. The biggest thing is we separate these composite figures into shapes that we know the formulas for, that we can work with, that are easy to work with, okay? And then I do have a joke to leave you with. It's a pretty good one today. So what did the baby tree say when it looked in a mirror? So what is it that the baby tree said when it looked in a mirror? And what the baby tree said was, gee, I'm a tree. Geometry. Got it? That's great. Okay. Hey, good luck. If you have any questions, please let me know. And thanks for watching, guys. Gradius out.